Hi everyone, let's dive into Lab 9. First of all, before you do this lab, you'll want to make sure that you've done the readings and the reading quizzes. I'm going to scroll down and just walk you through the lab. You're going to want to download the data set first, which I'm going to do. All right, that's done. Next, I'm going to download the lab instructions. And let's take a look and see what we have today. So for Lab 9, we're doing some data analysis on some data gathered, it's fictional data, gathered on children in Flint, Michigan, let's say. Because Flint, Michigan, if you will recall, has an ongoing crisis with their water, in particular the lead levels in the water. And so a group of psychologists wanted to know if these higher lead levels had any impact on children's IQ score and their motor scores. Motor meaning their ability to be physical and move and be coordinated and all that good stuff. So in this fictional study, 300 children were selected from the city of Flint, Michigan, and they are going to be compared on two different measures, the measure of their IQ and a measure of their motor skills, again, their physical skills. And we're going to assume that we know the IQ of the population, let's say of Michigan in general. We know the IQ of students in the population, and we know the motor score in the population. So we have a known population mean IQ score and a known population motor skill score, but we don't know the standard deviation, and that's why we're going to do a one sample t-test. All right, stay with me. Here we go. This assignment has 7 parts. First thing, we're going to upload the CSV file. We're going to do the gender labels, 1 for male and 2 for female. We're going to confirm that our scale variables are properly indicated. We're going to follow the directions in this sheet for doing descriptive statistics, which means we're just going to describe the numbers. But we're also going to do the one sample t-test, which is an example of inferential statistics. And then on your own, you're going to complete the worksheets, part 1 and 2 for this lab and submit your output. So we've got this. Okay, so I'm going to do the first part of the directions. So I'm going to go ahead and pull up JASP, and I'll browse for my file and my documents. There it is. Okay, so the first thing I was asked to do was to kind of just confirm my variables. So age is listed here as an ordinal variable, and it is not an ordinal variable. Age is a scale variable. You'll want to make sure that you change that. Gender is indeed nominal, and IQ score and motor score are both scale variables as well. Now, we were also asked to make our data labels, which you'll need to do for your output. So click on gender, and for 1, we're going to hit male, and 2 is female. Hit enter to make sure it takes. All right, so our data is now all completely set up. Let's see what's next. So we're being asked to go to the JASP analysis menu to descriptives and descriptive statistics. We're going to check the box for frequency tables, and we're going to move all nominal variables to the variables box. We've done this 100 times before, haven't we? Descriptives. And I'm going to move the nominal variable, we just have 1, to gender, and I'm going to hit frequency table, but do recall that we need to uncheck all these other statistics because we can't do these with a nominal variable. We can't find the mean, the median, and all that good stuff. Okay, so now we are set. We have our frequency table for gender. Let's see what's next on our list. Part 2 from the JASP menu, descriptives, descriptive statistics, move the scale variables to the variables box. Okay, so do recall that I don't want to start moving things around here. I just go back up to descriptives to start fresh. And this time I'm going to move age to the variables box, IQ score, and motor score. I'm not going to hit frequency tables because these are scale variables. They're equal interval or ratio variables, so we don't do frequency tables with that. We're going to take a look and see what we have. We have mean, standard deviation for age, IQ score, and motor score. All right, so we've got this. see what's coming up. So now we've done descriptive statistics. When we just talk about the means, the standard deviations, the frequencies, that's descriptive statistics. But now we're getting to inferential, which is, we're going to do that one sample t-test. So here we go. Actually, I'm going to take that back. We're still doing some descriptive statistics. Forgive me on that. So we are going to move gender to the split box and IQ to the variables box. And then we're going to do the same split with gender, but this time with motor score. So basically what we're going to be doing is looking at gender differences for both IQ score and motor score, but we have to do them separately. So I'm going to go to descriptives. I'm going to go to put gender in the split box. And I'm going to move over IQ score first. I've got that. I probably could do them both at once. Should we try it? Let's see. What happens if I move motor score over? Yeah, it works. You could do it separately. You could do it together. It doesn't matter. So here you go. So now I can compare IQ score between the males and females in this sample, and I can compare motor score between the males and females as well. This is important for when you're doing your lab worksheet today. All right, I'm moving on down the line. So we've now done all the descriptives, and now we're really, promise you, getting into inferential statistics. Okay, so this is just a little picture that's going to show you what we're going to do, but we're going to go to the JASP analysis menu. We're going to hit t-test, and we're going to select one sample t-test. And then I'm going to follow a set of instructions, and I can't remember them all, so I'm going to look at my paper as we do this. So I'm going to come back over here. I'm going to start the t-test, and I'm going to do a one sample t-test. I'm going to try to do this from memory, and then I'll check the paper to see if I've done it all. So the very first thing I'm going to do is I'm interested first in the IQ score. I'm pretty sure that's the first thing we're looking at. So I'm going to move IQ score to the variables box. But we have to do a couple different things. As you'll notice, it does start doing a t-test, but we haven't told JASP what the test value is or what the population mean is. If you'll recall from the paper, our population mean was 100. So I'm going to come down here to where it says test value, and I'm going to put 100. Now, I've put 100 in, but nothing has changed. It's because I have to click out of this in order for it to take. Okay, so let's do a couple different things before we start looking over there. You need to make sure the box student is checked because this means that we're doing a t-test. And then I'm going to move down a little bit, and we're going to select for a two-tailed test. And the way that I know a two-tailed test is I look for the alternative hypothesis, which says that the two means are not equal, the population mean and the sample mean. It doesn't say one's bigger than the other. That would be a one-tailed test. So I'm going to keep the two-tailed test. I'm also going to click this box for normality. I'm going to check for normality. I'm going to come over here to effect size and check that. I'm also going to click on descriptives, and then I'm going to make sure that this missing information is kept the same just by default. Okay. So what I'm going to do now is I'm going to come over. Actually, I'm going to do the next one first. So let me take a minute to look at what's next. Before we move on, you'll notice that the next analysis is just going to be everything we just did, but with motor score. We can't move motor score over here and do them both at once because we have a different test value for motor score. So we have to start all over, and that's okay. It doesn't take that long. So I'm going to come to t-test. I'm going to do a one sample t-test. This time I'm moving motor score to the variables box, and I'm just going to come down here and do a couple different things. Make sure that student is checked for the t-test. And this time the mean of motor score in the population was 50, so I need to change the motor score. And I need to click out of it to make sure it actually registered. I'm still going to be using the two-tailed test. I'm saying that for the alternative hypothesis, the two means are not equal. I'm not saying that one mean is higher than the other. I'm going to check this assumption check of normality. I'm going to click on effect size, and I'm going to click on descriptives again and keep these missing values just as it is. All right, it's time now to start looking at our output for our one sample t-test. Let's look at our first one sample t-test. For IQ score, we have a T of negative 8.5. That seems big, doesn't it? Our degrees of freedom are 300, which is our N minus 1, 299. And look here, our P is less than 0.001. Remember that for statistical significance, we're looking for less than 0.05. Well, this is way less than 0.05. So we're going to reject the null hypothesis. We say that our sample is statistically significantly different than the population. So we also have Cohen's d here, which we're going to look at because we do have a significant result, and we have negative 0.491. Now Cohen's d, you can calculate it, it'll show a negative, but we can just report it as 0.49. Okay, we do assumption checks to test and see if our data are normally distributed, and it looks like they aren't normally distributed. However, we do have a very large N, so we can rest assured that we're going to be okay with this one sample t-test. I'm going to go down a little bit further, and I'm going to look at how IQs or how motor scores were. We have a T of negative 3.390. Again, our degrees of freedom are here. And our P is still less than 0.001. That means that there is such a very low chance of finding our mean in the population of sample means, the distribution of sample means. So we're going to say that there's something really different about these Flint children. They don't really come from the same population of children who haven't been exposed to lead, for example. And then we have Cohen's d here. Again, you can get rid of the negative sign. Again, this is going to be the same because we have the same data set. There is a deviation from normality, but we do have enough people in our sample that we don't need to worry about that. All right, and then our descriptives are here, and I didn't mention that with the last one, but it shows that our mean was 47.35 on motor skills, and the population mean was 50, so we can see that we are definitely below the mean there. Let's go back up to IQ to see if we were above or below the mean. So our sample was quite a bit below the mean for IQ as well. All right, this is how we use JASP to conduct a one sample t-test. Go ahead and fill out the worksheet, submit your output, and you will be done for the week. I'll see you next week.